straight, man. Maybe let's do so. You see, I told you we were doing this. What usually I'm used to people being here. There we go. Right, good morning, everybody. Morning. Right, just quickly let the people that are online in. Can someone please give me a cloth, anything, tissue, something I can use just to wipe my. No, it's not necessary, man. Let's not waste that. It's okay. Yeah. Thank you. Not yours, just a small bit of it. Right, there we go. Right, good morning, everybody. Good morning, including those that are joining us from online, as well as on our channel. Happy Monday. How was the weekend? Busy. Okay. Tell us more. Busy. Okay, busy bee. All right. Mashle, welcome back. Siyabonga ukuthi you've recovered. By the way, guys, apparently there's just this bug that's been going around. The problem is that with the bug, you can never really know. I can't say, hey, you must be careful. When you catch a bug, you catch a bug. But yeah, I've come into contact with people that have had a bug, but for some reason I still remain, unaffected. So what I wanted us to do this morning is to look at the fundamental counting principles. But before I get started, a member of our class has lost her father. Kumo just contacted me this morning. So there's Kuto and then there's Kumo. We have Kuto in the class. Kumo has not joined us for a while because of the challenges that they've had, since as a family. So please, if you can, just reach out to her. We do offer our condolences to her and the entire family. But I think it would be really nice for us here to get in touch with her. No? Okay. Yeah, just to, and of course, we will see if there's any other way in which we can offer support. We can do so, but we will advise on that. Okay. Right. Just another reminder, Jay, as well. Please just note that we do have a robotics and coding workshop. I don't know whether to call it a workshop that we will be doing this coming Wednesday. So let's just make sure that we do submit our forms there to by today, because we need to submit those forms. May I please have my pen in my bag, man? All right. So for those of you that are joining us online, welcome on our YouTube channel. Please tell us, interact with us, tell us what it is that you'd like to see. We'll do as much as we possibly can to always accommodate you. However, we are meeting in this way only once a week for maths and once a week for science. This Thursday, I will be covering some revision session. Okay, so please do join us for that as well. All right, but let's get right into it. All right, fundamental counting principles. Okay, so I've heard that that's one of the things that you guys fear, right? Yeah, probability, probability, fundamental counting principles, this or that. Now, let me just categorically say this, that I do have my own approach that I do take on the fundamental counting principle. If you don't mind, I'm just going to call it FCP, right? I do have my approach that I will take on this. The essential thing is that we are looking at different combinations and permutations. Guess who? All right? Combinations and permutations, right? In fact, even to the point your calculator actually has a function called combination. All right? If you want to check, your calculator has an NCR, okay? And then you've got a combination, you've got also a permutation, but I won't go that route. Né? So what I'm going to do, guys, is that I don't want us to really clear a lot. I am just going to go on ahead and start with how I approach it, looking at it question by question. In fact, let me just do this quickly. Yeah, I think these ones have got a bigger space. What? Huh? What can't you see?
The size. It's fine, I'll use my phone.
No, but the size was still coming up. Oh. Yes. Okay. Right. So let's get right into it. So I use a block method. And a block method helps us in you being able to visualize whatever it is from a graphical perspective, right? And once you've done so, you'll see what you'll be able to actually answer just about any question, all right? You just need to think about, as I said, the different combinations and the different permutations that you have, okay? All right. Mamelo, are you with us? Are you with us? Okay. We're going to go blues room today. Huh? Okay. All right. So they say to us, let's start with the first one. They say a password must be 4 characters long, right? Now I want you to think about it. So if I say to you a password has to have 4 characters, so what I'm going to do is I'm going to make a block that has 4 spaces in it, okay? Right. They say each character must be a 9-digit must be a digit rather, that's 0 to 9, or a capital letter, A to Z, right? Now they are asking us how many possible passwords are there. Now, the thing about it is that So they haven't given us a restriction. Are you guys with me, ne? Right. So in certain instances, they'll give us restriction. They'll say to you, if it is that you can only use one letter once, or no repetition is allowed, right? Or in this case, they can say you use, the condition might be to use 2 digits and 2 letters, or whatever the case may be. In this case, they've given us a combination of words, all right, of digits, as well as letters, okay? So, how many digits do we have? How many digits do we have? 9, huh? How many digits do we have?
10.
We've got 10, right? When we include 0 in there, right? So we've got 10 digits. How many letters do we have? 26. So each of the blocks can either be a letter or can be a digit. Right. So how many in total can we use? How many can we use? That's the 10 plus the 26. Are you guys with me now? Right. They didn't give us any restriction. So if repetition is allowed, right? In this case, how many can I use in the first block? I can use 36, isn't it? So I can use either a letter or a digit, so that's 36. All right. If I've used the first one, right, how many can I use in the second block?
36.
Still 36, because I can have a password that is just LLLL. Okay? Or I can have a password that is 0000. Okay? So how many can I use in the second block? 36. How many can I use in the third block?
36.
Still I can choose from 36, right? Okay, and how many can I use in the last block?
36.
Still I can use 36. So which means all that we are going to do, in order for us to find the total number of possibilities that I can have here, that means I will just simply say 36 to the power of 4. Does that make sense, guys? All right, so that means it's 36 times 36 times 36 times 36, and that will give us the number of passwords that are possible if repetition is allowed. Are we together, ne? All right, beautiful stuff. So that's the A part of it. Okay, so let's look at the next one. They say to us, what is the probability that a randomly chosen password has no repeated letters? Now note, we are not allowed to repeat letters, but we are allowed to repeat numbers. Do you see that, no? Right, so let's do that again. Okay, we've got a block. And we've got another block. Right. Now, in this case, I want you to note that we've got, all right, we'll talk about that here just now. So in the first block, I can either use digit or I can use what is it? A letter. Are you guys with me, ne? Right. So please tell me, in this case, in the first block, so if I said to you, okay, how many possibilities are there? What can I use? All 36 letters, all 36. All 26 letters rather, and all 10 digits. Are you guys with me now? So how many can I choose from? 36. Okay? Now, in this case, on the second one, well, how many can I choose from? 35. Okay? Now the question is, what if it was a block? What if it was a digit that I chose? Are you guys with me now? Right? So the only thing that I cannot use is a letter. Okay? That I cannot repeat. That's a letter. But in this case, I am allowed to use digits. Are you guys with me now? Right? I am allowed rather to They said, what is the probability that the randomly chosen password has no repeated letters? Okay, right. Now, in this case, I want you guys to note. Let me do this. I'm going to make an OR over here. And the possibility that I want us to look at is, let's make two separations between letters only, between digits only, right? And we are going to put them together, right? Why? Because in this case, the problem is that here, I'm looking at a possibility or a combination of digits, and I can't repeat the digits, right? And I therefore cannot say it's 36. Now, let's just say the first option is going to be just digits only, right? So how many digits can I use? 10. Okay, so that's 10, right? Once I've used the digit, can I repeat? Yes. Yes, I can. So what is it? That's also another 10. And then 10, okay? What if I used 3 digits? That's 10 again. Are you with me now? Right. Now, I am going to say, all right. So when you say or, in this case, we always add. Are you guys with me now? Right. So I'm going to take the digits only combination, and I'm going to add it to a letters only combination. All right, we are talking about the number of possibilities. So again, in this case, in the first block, right, now we are talking letters. How many letters can I use? 26 in the first one. Ne? When I've chosen one, I can't repeat it. How many can I use in the second one? 25. I can choose from 25. All right, now that I've used 2, I cannot use them, I cannot repeat anymore. How many can I choose from? 24. I can use 24. Now that I've used the 3, right? And now how many can I choose from? 23. That's 23. All right. And so that will be my combinations. Okay? Right. But do you remember, Guti, they didn't ask us for the number of outcomes that are possible? But what did they ask us? They asked for probability, right? So in this case, I want you to note that once we talk probability, we are always going to take the combination that we have divided by the total number of possibilities that we have, right? So what was the total number? It was this 36 to the power of 4, isn't it? Okay, right. Firstly, give us an answer for that. Oh, it's okay. It's okay. The second one? The second one? Okay, so now we've got 10 to the power of 4. Okay. All right. Let me rather put it this way again. You are going to get answers for both number 1 and number 2. Né? Right. So for number 2, I am looking for the probability. And so the probability will be the combination that I have here, which is 10 to the power of 4 plus 26 times 25 times 24 times 23. Okay, so let me just make some space there. 10 to the power of 4 plus 26, 25, bless you, 24, 23. And this is divided by the total number of possible outcomes. And what did we say the possible outcomes are? This is 36 raised to the power of 4. Are we all together, guys? No? Right. And don't worry, we're still going to take more and more of these as we continue. Okay. Right. But I really find this block method a little bit more, fathomable, but than using all of these formulas that we've got. No? All right. Yes.
Can you please explain why it would have been incorrect for B to be like
36, 35, 34, 33. Okay. Right, that's a very good question. So, she's asking, would it have been incorrect for us to say, okay, we had 36 possibilities, right? And then 35 thereafter. Now the presumption, if we said 36, 35, 34, 33, the presumption would have been that in the first digit, let's say, right? I mean, in the first block, we're assuming that we would have used what could we not repeat? A letter, okay? But do you also agree that there was a possibility for us to use a digit? Right? So what if we use the digit? We still have all 36 that are still there, right? What if we use a digit again for the second combination, right? Well, we still have how many to choose from? We still have another 36. Do you agree with me, no? And so if you ended up with digit, 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 digit for the password, then in that case, you are back to square one. Are you with me now? So then we had to make a separation between digits as well as letters, right? And say, okay, what if the possibility was that we were using digits only, right? There's a total combination of just digits only. And the digits only combination, that's where we could find what we could repeat, right? That's a 10, 10, 10, 10. Or we could use letters, right? And now letters angangena anyway, right? So in that case, that's where we say, all right, how many letters can we choose from, right? Now I am separating the two because the outcomes for the two are different, right? In that case, for the letters, we couldn't repeat, so that's why we could say 26, 25, 24, and 23. Okay, right. So whenever you'll see, whenever we end up with an or situation, we're always going to say plus, we're going to add the two possibilities. Okay, right. Is this right, guys? All right, beautiful stuff. What a difficult one to start with. Okay. Let's go for the second one, and you'll see, you'll get used to it. Né? They say to us, license plates. So we've got a license plate consists of 2 letters followed by 3 digits. Okay? They say letters may be repeated and so may digits. Okay? So we've got a license plate. Here's our license plate. Now remember, in our license plate they said we can use 2 letters. So this is letter, and they said 3 digits. Né? This sounds like a KZN number plate. Okay? Right, so that's letter, and we've got digit, digit, digit. Right, so please stay with me on this one. Né? So, they say how many license plates are possible? All right, what did we say? Repetition is allowed, isn't it? Okay, how many letters can I choose from? 26. All right, so we're going to say 26. Okay, once I've used the first letter, can I repeat again? Okay, so how many combinations, how many possibilities can I choose from? 26. That's 26. Okay? All right, and now I'm moving over to the digits, isn't it? Okay, so how many digits can I choose from? 10. All right, at least and 39. All right, so if I've used the first digit, how many can I choose from? 10. I can choose from 10. Right? If I've used 2 digits, how many can I choose from? 10. All right, another 10, because repetition is allowed. Are you guys with me now? All right, so what would be your total outcome in this case? That would be 26 squared multiplied by 10 cubed. Okay, so that would be your total number. So 26 squared multiplied by 10 cubed. Okay, right. So for the next one, and you'll see, Guti, deliberately I've made it in such a way that we are calculating probability. Ne? Okay, right. Now they say to us, what is the probability that a plate starts with the letter M and ends with an even digit? Okay, so what are we looking for? Letter M, right? And then we are looking for even digits. Let's see, how many combinations can we make like that? Are you guys with me, ne? Right. So, here's a license plate. Okay. One thing that we also need to note, they did not tell us that repetition is not allowed. Are you guys with me, ne? Right. So, we want the possibility of starting with the letter M. Yeah, they did not say, they said repetition is allowed, ne? Right. So, let's start on the first one. And it is fully probability of using what? The letter M. All right. How many letters can I choose from on the first letter? One. Okay? Which is M, right? So there it is. There's only one letter M in the 26 alphabets. Okay? Right. In the second letter, how many can I choose from? Okay? Now remember, we did say repetition is allowed. Okay? So which means, how many could I choose from? I can choose from 26. So I could have the letters MM. Are you guys with me, no? That's allowed. So in that case, it means that I've got 26 that I can choose from. All right, what about the digits? So digit number 1, digit number 2, digit number 3. Again, repetition is allowed. Okay? Right, let's start at the end. Let's start at the end. At the end, we wanted a possibility of having an even number. Are you guys with me now? Right. How many even numbers are there? Eh? How many even numbers? Eh? Okay. Is 0 an even number, guys? No. Okay. Mara, if 0 comes with something, it makes it an even number. Are you guys with me, no? So for instance, if I have a 1, 0, that's an even number, isn't it? Okay. However, we just wanted an even digit. Okay, so meaning that we're looking at that as a standalone digit, which means 0 is not included. Are you guys with me now? Okay? Right. So, in that case, how many digits can I choose from in the last one?
4.
I'm choosing from 4 digits. Okay, so first digit? First digit? 10. Repetition is allowed, isn't it? Okay. Second digit?
10.
Okay. There we go. So that would be the number of possible outcomes that we can find. Now, we're not just looking for the number of outcomes. So what are we going to do? Multiply that, multiply that. Okay. Right. What is our total number? Yes, please go ahead.
So why is the even digits 4? I thought it was 5, so it's 0, 2, 4, 6, 8.
Maybe we can argue about this. Is 0 an even digit? Eh? It is. Because it is divisible by 2.
Yes.
It is divisible by 2. 0 divided by 2 is 0. So, is it an even digit? I guess when we argue it like that, can you Google there quickly? Is 0 an even digit?
Google says yes, I just Googled.
All right, Google says. Okay, thank you. Okay, so Google says yes. All right. Okay, so that makes it 5. Thank you for that. Who was speaking just now? Oh, Aviwe. Okay, thank you so much. All right, so there we know manje, ne? We know that 0 is an even digit. All right, what is the combination that we can get? Okay, so we've got 1 times 26 times 10 times 10 times 5. That gives us the total number of possibilities. No? But what was the question? It was the probability. So our probability in this case, we're going to say, well, what is the total number of outcomes? So it would be whatever the product that you got there. That's 1 times 26 times 10 times 10 multiplied by 5. And this would be divided by 26 squared multiplied by 10 cubed. So whenever it is that they say to you, we must calculate the probability, we are always going to take the number of possible outcomes, right, divided by the total number of outcomes. Are you guys with me now? All right, beautiful stuff. And that is where, and by the way, please remember that your probability, if you get anything more than 1 for your probability, then it means there's something that you did incorrectly there. Are you guys with me now? Okay, beautiful. All right, I'm leaving the next one to you again. Right, so they say to us, we've got 7 friends that are to sit together in a row, right, of 7 seats. In how many different ways can they be arranged? Right. Unlike letters and digits, these are peoples, right? So, in that case, we've got 7 of them. In the first seat, how many can I choose from?
7.
I can choose from 7, right? Once I have 1 seated, how many can I choose from?
6.
Once I have another one, 2 seated, how many can I choose from?
5.
Okay, I've got 3 seated, I've got 4, I've got 4 seated, I've got 3, I've got 5 seated, that's 2 and 1. So this is where I can now say, what is the total number of possibilities? We say 7 factorial. Okay. Those are the number of outcomes that are possible. No? Right. And now, they ask us the question, if A and B insist on sitting together, in how many ways can they be seated? Maybe let me give you a bit of a while to think about this. Okay? This is Baba Lo and Mlebufeng. They're insisting with no, we want to do robotics and coding together. I think there was a question from online.
No, sir, it was just because I said he wants us to think about it.
Oh, okay, okay. Yeah, you are welcome to give us an answer. Or do you still want some time? Still want time? Oh, no. I'm asking the people in class. Sorry.
Okay.
I'm asking the people in class. Got it? 2 minutes. Kusele 3 minutes. What's our second?
Yes, that's okay. I'll wait for them.
Okay. What's our second? Winning. Agathanda ama yellow bone. Nina entsasa ma cream. Let's take out the names. Okay, I want to see what you guys are doing. Aish. And I don't have a device, man, to check for comments from my YouTube people. This is if you're looking at the one, it's just one. But we did prefer to see together. But then we don't know which one. So which means we also need to multiply this. Does that make sense? For the probability. Okay?
My friend is also they exist anyway.
Yes, absolutely. Absolutely. No, 5 factorial does it. What you already you could start with the 2, right? Or if you place them, right, then you are left with. So you are looking at the 2 as just one combination. Right? So that's you understand why I'm saying multiply by 2, right?
Was that the same thing with 5 factorial times by 2?
Yes. So that would be 5 factorial. Absolutely. Not unless it's predetermined which one goes first.
Oh yeah, they are. I think it doesn't matter.
So, meaning that. So let's take the 2. So how many combinations? So we've got the 2 as 5 as 1. This was a 5. That's good. 5. Yes, okay, sorry. So that's not 5 factorial, that's 6 factorial. Okay. The 2 are using, so you still have to 5. So we've got.
But it's 1, 1, 5, 4, 3, 2, 1. So it's 1 times 1.
So we're looking at, remember, these are placings, right? So you can either start by placing the 2, or you can start by placing any of the other 5 people. Okay, so we've got actually 6 places. Okay, it's fine, I'll explain just now. So we've got 6 possibilities. I don't know if you guys. So either you can just place the 2, and then you still have 4 more. Or you can start
it's like this. Always wants to do places that is that's okay.
So you look at it. So that means that as long as they are
like 2 horses. So like 3 stations, 3/4 of all the states. Just like 1 state. So that's the prefectural farm.
So once you have
So it's as a unit, and then
the once you have one city,
and then the 2 for 12 interchanging.
get it, man? But remember, living between them, we still now need to consider that we need to solve them. Right? You can either start with the one or the other. So there's still two ways of there's only one person in that particular. There's an order that's but in this case, because we were not described an order,
What happened? The same. It's actually 2 factorial, but 2 letters and things that's just when you think about almost there. And you just need to consider so when you have the 2 of them, I think that's Don't make so much class. So mostly
Okay, okay, so 6.
Yeah, take them. So 5 other single units.
No, I'm saying.
So which means it's 6.
Oh, it's just
Because we can either place them first and then we've got 5 more to go.
then it's fine.
Hold on, I need something here.
But the thing is one is this and then the other one.
You know very well what to illustrate, huh? Okay, we'll illustrate it right now. Okay. You know, there's some interesting arguments that are happening. I want us to think about it. Okay? Aviwe, tell us your thoughts. You wanted to say something. You were so keen to give us an answer.
So I think since the learners want to sit together, they obviously one group and then the rest of the others. I don't know how to put this. I would first write like 7 blocks, the blocks of the children.
Okay.
And then I just give them names or just say learner 1, 2, 3, 9, or ABC since they sit on ABC want to sit together. And then I will group them into, and I'll take my pencil and I will group them into one group and then the rest as individuals. And from that one group of A and B, they are 2 learners, so that means there are 2 possibilities that they can sit. So I will write on top 2 factorial, multiply by this, multiplied by the rest of the learners, which are 5 learners, plus A and B because they are one group. So there will be 6 factorial multiplied by 2 factorial.
Okay, beautiful. I completely agree. Right. So did you guys get that? Okay. So, and I want you to really think about it. So we've got 2 A and B, right? Which are the 2 learners. We are taking them as one. Are you guys with me now? Right? How many more people do we still need to get seated? How many more people do we still have, rather? 5. We still have 5. So which means it's the 2 that are one bundle, and it's the 5 that we need to get seated. They didn't say to us we are going to start with the 2, right? So meaning at the beginning, how many can we choose from? At the beginning, when we start with the first block, how many can we choose from?
6.
We can choose from 6. So we now have 6 possibilities because the 2 have decided that they will just be taken as one. Are you guys with me now? So we can either sit the 2 or 5 of the students, or in this case we can sit 1 student and then follow with the 5. Okay? It doesn't make sense. Okay. So which means at the beginning we've got 6 to choose from, right? And then once we've got, remember we are taking these 2 as one, né? Okay, we'll come back to the 2 of them. All right. Now we've got 6 to choose from, and then how many? Once we've got 1 seated, we've got 5 to choose from, right? Once we've got 2 seated, how many do we choose from? That's 4, that's 3, that's 2, and that's 1. Now, I am not saying in any way that we can preempt in this case, but we've got A and B, right? So between them, they just prefer to sit next to each other, right? So there's no particular preset order between them. So there's 2 possibilities. I can start with A, then follows B, or I can start with B and then A. So even within them, there's two possibilities. Does that make sense? Right? So even within that block, I don't know how to represent it nicely, but so if I did this, for instance, I'm taking them as one block, and then I've got the rest of the other people, right? So we said we've got 6, we've got 5, we've got 4, we've got 3, we've got 2, and we've got 1. But let's assume that the first block is made out of the 2, A and B, right? What do you note between them? That I could still say this is A and the other one is B, or I could say we start with B and then A. Are you guys with me now? So in this case, there's two possible outcomes for them. So besides the 6 factorial, I am going to multiply by the 2 factorial ways, and 2 factorial is just 2. Nah? Okay, so what is the total number of possibilities? 6 factorial multiplied by 2 factorial. Does this make sense, guys? Kutlwano ngati is not make sure. Nyaksugel,
No, so just.
you're processing it.
Yeah.
Okay. Nifuna siyenze practical.
Can you just repeat?
Repeat what I said. Okay. Ngicela 7 people bazongijoin.
Please ask Abby
To repeat her way. This is exactly what she did. This is what she was explaining.
like
Eh? Okay, Aviwe, they prefer your voice. Please tell us. I wish I could get you to write. Please tell us what you did.
It's me. So I don't know how to. It's difficult because you're not in person.
Okay, yeah, because I'll try to write whatever it is that you're saying, but I think you and I were saying the same thing, right? But I want you to explain it in your way, because Umobile seems to understand you better.
Okay. Can you please throw 7 blocks for me?
7 blocks for you, okay?
Yes, please.
Okay? Right, there we go.
And then name the letters A, B, C, D.
A, B, C, D. Should I write this within the blocks or outside?
Yes, sir, so they can see it visually what I'm talking about.
Okay. A, B, C, D, E, F, G. Okay?
Can circle A, B as one group because they must sit together. That's a limit. And then from this, what we have from this drawing, AB is 1 unit, and the rest are also a unit individual. They are a unit individually.
Yes.
So AB is 1 unit, C is 1 unit, D is 1 unit, and in total we have 6 units.
Yes.
So that 6 units will be 6 factorial because it's first going to be 1 learner, 6 learners, and then 5 learners, and then 4 learners, and so on. We understand that. And then you must look at it as from A and B. A and B can sit in 2 different ways because they did not say that.
Aviwe, please, can you please come and take my place? You've said what I was trying to say in the simplest of ways. Okay, yes, continue.
The reason why we're going to assume that they can sit in 2 different ways is because we were not given an instruction that says A must be at first or B must be at first position or B must be at second position. So we're going to assume that they can sit in two different ways. That's how we're going to say 2 factorial. And then we're going to multiply the 2 factorial by the 6 factorial.
Posa. Ha! Posa. I think that was, that's a really, really nice way. You know, I was trying to say this in the most visual of ways, noted, ne? I was trying to say this, but you've really broken it down in very, very simple terms. You see, this is the power of collaboration. Ne? Okay, Antibale?
Sir, we also got the same answer, right?
You got the same answer.
But-
Mara, you did something different. Okay, tell us what you did.
Okay, so, our sum is 2 factorial multiplied by 5 factorial multiplied by 3 factorial.
Okay, say that again.
2 factorial
2 factorial
multiplied by 5 factorial
multiplied by 5
3
multiplied by 3 factorial.
Yes.
Okay.
So, right, 7 blocks, I'm going to use the AB.
The AB analogy. Okay.
Yes.
All right.
So, AB.
AB.
Right?
Uh-huh.
For the 2 factorial, we're assuming that AB
Okay.
are sitting at the first 2 seats.
Okay.
Right?
All right.
That's when we get our 2 factorial, right?
Uh-huh.
So, from C to G, we are left with 5 seats, right? But C, D, E, F, G, they can also interchange. Like G can sit go C, C can sit go G. So we get 5 factorial, right?
Mhm.
And then our 3 factorial, A and B.
I'm trying to visualize what you're saying. So you're saying we're taking A and B,
Yes.
and they can sit where C and D is.
No.
Huh?
Our 2 factorial,
Yeah.
we are saying A and B are sitting at the first 2 seats.
Oh, okay. So
Yes.
you've already allocated them.
Yes.
Okay, that's
And
great.
then my 5
Mhm.
factorial is from C to G. That C can sit
Okay.
at
So
G.
you are just okay. So you've eliminated these 2, right?
Yes.
We've already allocated them.
Yes.
So now we are only focusing at C to G.
Mhm.
So that's your 5 factorial.
Yes.
Scooty's nice.
And then we have multiplied by 3 factorial.
Multiplied by 3 factorial. Hold on. Where does the 3 factorial
Yes.
come from?
So our AB, right?
Mhm.
They can sit for C, D as a group, E, F as a group, right? Do you get what I'm saying?
Yeah.
Like
So
if they're not placed first, they can sit at any other position but as a group of 2. And because we have 7 seats, they only can be placed twice, like A, B, C, D, E, F, G's and
odd.
layers.
Yeah.
So you can say 2 factorial multiplied by 5 factorial multiplied by 3 factorial multiplied by 1, but it's still gonna give you
The
the
same.
same answer.
Okay. All right. So that's an interesting one. Okay, that's an interesting. It's good. Okay. And you got the same answer, no? Okay. You see, I think this visualizing AMA blocks thing kind of works because you're able to then make a different permutation for yourself. All right. Right, and the last question, they said, what is the probability that A and B sit together if seats are assigned randomly? All right, do you see? We went from possible outcomes, right? And now we are going probability and all there is to it. And you'll see, guys, even when they ask in the exam, there'll always be that pattern in a sense. Né? Okay, so the probability, in this case, Tina Site 6 factorial multiplied by 2 factorial divided by the total number of outcomes, which is 7 factorial. Or if you used the method Yaga, Ntibaleng, and Andile, that's 2 factorial multiplied by 5 factorial multiplied by 3 factorial. Honestly speaking, I wouldn't have seen this, okay? But I think this is the one beautiful thing about getting multiple perspectives, né? Multiple perspectives. So this is really, really good. All right, and so that is the probability. School is nice? All right, you guys are on the roll. Namhlanje. Okay, let's go to the next one. Let's go for the next one. Clothing choices. So, here's a student. Yes, that is. Oh, sorry. I didn't see. Okay, pin code. So they say a pin code requires 6-digit pin code, or rather, a bank requires 6-digit pin code. Each digit can be used, can be any number from 0 to 9. How many different pin codes are possible? You can give me the answer, ne? Excuse me? Right. So clearly, you can have a pin code that is just made out of the same digit, right? Okay, repetition is allowed. There was no restriction that is given. Right. And then for the second one, if they told us that repetition is not allowed, fundamental counting principles we can't do. Look at you now. Huh? Busy counting stuff. Okay. Talk to me. We said on the first one, that's 10, that's 10, that's 10, that's 10, that's 10, and that's 10, right? Repetition was allowed, so which means we could say 10 to the power of 6, isn't it? Okay. But now, on the second one, they said repetition is not allowed. What does that tell us? Sorry that my blocks are so... Okay, so how many can we choose from for the first block? Why are you squinting your eyes? Eh? So once we've used one, how many do we have? 9. Don't see, Pani. Okay, so how many can we choose from? 9. And once you've chosen 2, okay, that's 7, that's 6, and that's 5. Okay, right, so you can say that this is 10 times 9 times 8 times 7 times 6 times 5. Okay, right, that would be the total number of outcomes that are possible. Good? All right, was this clear and straightforward? Né? All right, now we can go to clothing. Definitely that must be a male. That must be a male.
Yeah.
That must be a male. Because there is just no way. There is just no way. The other gender, 4 shirts, never. You know, Tina, we are very minimalistic, ne? Very frugal. Huh?
No, so it's not that. So it's not that. Your clothes are expensive.
It's not even the thing, you know? Like, it's not even a thing. Huh?
Like what I can get at 10K is not what you can get.
You're even going 10K. Whew. Already I have heart palpitations. You just mentioned a figure. Okay.
Okay, 1K, sir.
Okay.
1K.
I will only get 1K.
What are you going to get for 1K?
Girls, the shirts.
Let's realistic, the jeans themselves are like 300.
Okay. Let's go for it.
You're not getting that much.
Whilst they're arguing, like last scene, who has more clothes than the other?
No, I'm just talking realistically. How much clothes can you get for 1K? Because clothes are expensive.
On Timu or there's a shirt for 6 rand. Huh? Okay. Guys. Okay, let's come back. Right, so they say to us we've got a student that has 4 shirts, 3 trousers, and 2 pairs of shoes, right? So when we've got a question like this is very kind of simple to kind of find the combination yakona, because for every one of those shirts they have 3 trousers to choose from, but they don't have 4 shirts. I mean, they don't have 1 shirt, they have 3. So all we are going to do is that for the possible number of outcomes, we're just simply going to say 4 multiplied by 3 multiplied by 2. See, right? Yeah, it makes sense, no? Okay? Because that's, they can exchange. So how many outfits can they put together? 24. 24 outfits. At least that's a month. Right? Yeah, that's a month's worth of outfits. So do you see what you don't need? Especially the ladies, you don't need all of those shoes in your wardrobe. You just need 2 pairs. You just need 2 pairs. Okay, let's go for the next one. Guys, do you mind if I can just maybe borrow someone's phone? I'm phoning on my phone. Can you borrow me your phone? You don't have your phone. Okay, I just want to, can you please go to the live, just lower the volume? I just want to see if there are any questions, maybe. Yeah, on YouTube.
Isn't it your premium people?
No. Anyone can be. I think. I don't know. I don't know. I'll have to ask.
People, it wouldn't appear.
Okay.
Yeah.
Oh, is it?
Oh, it shows.
It shows, ne? Okay. All right. Can you moderate it for me? Let me know if there are any questions so that I can be able to address them. Okay. Whilst they check for questions, they say if chosen randomly, what is the probability that the outfit contains the red shirt? Aha. What is the probability that an outfit contains a red shirt? How many possibilities are there if I use the red shirt? We're assuming of the 4, one of them is red. Okay. Yeah? Okay. Now, do you agree with me that a red shirt is a specific shirt to choose from amongst the 4? Do you agree? So, how many shirts are there that are possible? 1. Right? It's the red one. But do you agree with me that they can wear that shirt with all the pants that they have? Right? So, how many pants? Trousers. That's 3. How many pairs of shoes? Okay, so how many outfits can they put together just using the red shirt? That's 6. But what were we looking for? The probability, right? That the outfit that they are wearing has a red shirt. So in that case, that would be 6 over the 24. Okay. Is it right, guys? All right. Beautiful stuff. Okay. The exercises from number 10 start becoming meatier. Okay, please can you do question number 6 and number 7 for me very, very quickly. I thought this was very interesting, yes? Your multiple choice. You know, can I tell you a story, guys? The first time I got a 0 for a test. The first time I got a 0 for a test was a multiple choice question paper. Yeah. Huh? Yeah, I told you. I tell you. Only to find Wuti the memo had only one letter. That was a possibility. And mind you, when I got to number 6 and I realized, nah, man, you know, I kept circling A. I thought, nah, but that's not possible. And then you start looking for other possibilities, you see. Got 0. So I think my point to this is I'm saying, I know you guys get excited when we say it's going to be multiple choice and people go, yes! You better think again. And the way to go about multiple choice is not this, guys.
I think that's great.
I tell you. All right, I'm gonna take this one to our online community. I know you guys have been dying to answer. Right. Anyone online wants to take this one? Eh? You're not sure? Yes, I'm going to there are 10 questions.
The confusion is here because there's A, B, C, D, right? And
Okay.
then it's asked 10 times.
Yes,
And then there's
but think
1,
about
2,
it.
3, 4, 5, 6, 7, 8, 9, 10.
Okay, so we are saying, how many possibilities are there for the first question?
4.
There's 4. Right? Then we move on to the next question. So that's why there are 10 blocks. Right? Because you've got different possibilities for each question. All right. Does that make sense? Makes sense? Okay. So, for the first question, how many possibilities are there? Are there any questions there? No, not. Okay. How many?
4.
There are 4 possibilities. Okay, for the second one?
4.
That's 4. For the third one?
4.
So do you get it? No? It's 4 throughout. So what's going to be the number of possible outcomes, or rather the number, possible outcomes? Right, that's 4 to the power of 10. Does that make sense, guys? All right. Now let's go for the interesting one. Nitulile has online. Nitin, what do you have to say for yourself? Okay, they say, what is the probability that a student gets at least? So that's the operative word, ne? At least. 1. So meaning that getting the right answer can be either 1 or more than 1. Talk to me. What's the probability? Because I'm a little bit lazy, just going to remove these. I'm going to use the same blocks. Okay. May I ask this question? Because it would be difficult for you to actually find this possibility. Right? So, can I change the question a bit? What is the probability that a student does not get any answer? Would that be easier to do? That's a bit easier. Okay? How many answers, how many wrong answers are there?
3.
Right? There's 3, right? Right?
Yes.
So what's the probability of getting all the answers incorrect? So, in my first block, how many to choose from if I wanted to get it incorrect? 3. In my second block? In my third block? So it's 3 all the way, isn't it? Okay, now I want you to please listen very carefully. So this is where I can actually use the complementary rule. All right? So the possibility of getting at least, and remember, I'm looking at a combination, and I'm saying at least, at the very least, right? But how many possibilities are there, right? So in that case, I can say, well, this would be 1 minus the probability of getting all your answers wrong, incorrect. Does that make sense? But what's the probability of getting them incorrect? Well, in this case, the probability of getting them incorrect, you said to me, this is 3 to the power of 10 divided by 4 to the power of 10. The number of possible outcomes that are there. Awukho happy, yes? Awukho happy. Okay. Where have I lost you? My man. Now, do you agree with me? Okay, let's say I said to you, what's the probability of getting the first answer? Not probability. How many correct answers are there in the first outcome?
1.
As 1. And then, second one?
1.
Do you see the problem that we'll run into? 1 to the power of 10 is?
1.
So the problem is, I can't do that by looking at the right answers. So I need to now flip the script. That's where the complementary rule comes in. Now the complementary rule says the probability of an event taking place, or rather, the probability of an event not taking place is 1 minus the probability of that event taking place. You get it, ne? Yes, guys?
Yes.
Now, if I wanted to get at least one, in that case, I'd end up with that possibility. But if I say to you, what's the probability of getting no answer correct? Then, how many possible options are there in the first question? You said 3, right? If I wanted to get the answers incorrect. Hello? Lisa said right? Okay. Right. 3 to get the answers incorrect in question 2. The same is true for every other question. Are you guys with me now? So meaning that the number of outcomes is 3 to the power of 10. Are you guys with me now? Right. Now, if I said to you, what is the probability that the student will not get any answer correctly? Right? No answer, not even one. What would it be? You'd say to me the probability is 3 over 10 divided by the total number of outcomes, which is 4 to the power of 10. Does that make sense? Right. This is the possibility of not getting even one correct. But what was my question? What's the probability of getting at least one? Which means 1 and more. So to get 1 and more, that will be the 1 minus the probability of not getting even one correct. Probability of all of them incorrect. I hope that makes sense, guys. So this is 1 minus the probability of 3 to the power 10 divided by 4 to the power of 10. So I can say this is 1 minus 3 over 4 to the power of 10. I hope that's clear now. All right. Okay. I wanted us to try and see if we can at least get till number 10. Nah? Let's see. The next one says we've got a seating plan. 6 friends are to sit in a row. There we go. They say 2 friends insist, sorry, on sitting next to each other. It's essentially the same as that one. Nah? Okay. Okay. So 2 friends insist on sitting next to each other. In how many ways can they be seated? Mm-hmm. How many ways can they be seated? $240. Okay. How did you get that? 5 factorial, right? Because remember we had 6 students, right? But these 2 must be grouped as 1. Okay. Right. So that would simply be 5 factorial. So which means if we use that ABCD analogy, Avu, I'm going to steal it, ne?
It's fine, sir.
All right. Is there copyright?
No, sir.
Copyright. Apparently, copyright means it's my right to copy.
Really?
No, I'm kidding. That's. It actually means the opposite of that. Okay. So if we took again A, B, C, D, E, F. Right. Now remember, We said that A and B must be bundled together, right? Okay. Right. So if they insisted on sitting next to each other, so how many do we have in that case? How many possibilities are there? We've got 5 factorial, right? Okay. We've got 5 factorial. But what else do we know?
Those two
Huh?
people are interchangeable.
Because the 2 people can be swapped, right? Can swap seats. So in that case, it means that if I were to take these 2 as 1, in that case, it means I can say, well, that's 1, 2, 3, 4, 5, right? So that would be 5, that's 4, that's 3, that's 2, that's 1. But between A and B, we still needed to, we can swap them around. So that would be 5 factorial multiplied by 2 factorial. In that case, we get our final answer. Are we all okay, guys? No? Mm-hmm. Right. And then let's go to the how. Is that it? Sure. Okay. All right. Quickly. A car lock uses 5-digit code. Each digit can be 0 to 9, but no digits can be repeated. How many codes are possible? Mm-hmm. All right, how many can I choose from in the first block? Can choose from 10 digits. Once I've used 1, how many can I choose from? 9. Once I've used 2, how many can I choose from?
8.
Okay, we get the drill, no? Okay, so those are the total number of outcomes that are possible. All right, and then menu choices. And now we go to restaurante. At a restaurant, you can choose starter. There are 4 options for starters. 1 main course, there's 5 options, Yama main course, and 1 dessert option. Okay? 1 dessert, there are 3 dessert options. Right, how many possible meals can you order? Right, okay, so we get it. It's going to be 4 times 5 times 3. All right, so there are 60 different meal combinations that we can make from that. Is it right on it, guys? All right. And then the last one has to do with word formation. They say from the letters of the word algebra, how many different 7-letter arrangements can be formed? The hint is that notice that some letters repeat. Okay. Remember, we are using 7 letters, ne? Some letters can be. Calculate the number of distinct arrangements. Okay? Yeah. Talk to me. How many letters can I choose from in the first one? 6. Why 6?
Because there's 2 A's.
Okay?
It's 6.
Right. So I want you to note in this case that that A, from what it seems, because it's a 7-letter word, we're going to take that A as a different letter. Okay? Are you guys with me now? So I'm going to call that other A prime, so that you can see the distinction. So on the hint here too. Okay, I'll come back to that in just a bit. So how many letters can I choose from? Right? I had 2 A's, sorry, that are possible. But remember, I still need to put a... Yeah, actually there are 2 ways in which we can approach this. Yeah, maybe can I talk about it in that way, guys? Nah? Okay? Firstly, I'm going to assume that the 2 letters that are similar are different. Is that okay? Right. So, let's talk about it. So the first way is if. So how many letters can I choose from in the first one? I'm assuming that the 2 letters that are the same are different. Okay? So let's call the one A and the other one A prime. So how many can we choose from? That's 7. Okay, once I've chosen one, how many? That's 6. Once I've chosen, and then? Okay. So that would be 7 factorial. Right? Now, if they say to me that repetition is not allowed, the problem is, do you agree with me that we can't form a 7-letter word? Do you agree with me? Yeah. If they then put a restriction that repetition is not allowed, in that case we can't form a 7-letter word because then it means that the letter that appears twice cannot be used once it's used once. Okay? So how many combinations do we have? In that case, okay? Right. I want you to think about it. In the first instance, how many letters can I choose from? How many can I choose from?
6.
Okay. Yeah, I've got 6 actually, because then I'm taking those 2 as one. Eh? Yeah, because I was trying to think I have 7, including the other A, in case. Yeah, no, it's not going to work. So that's going to be 6, 5, that's 4, that's 3, that's 2, and 1. Is there a question?
Yeah.
The first one, yes.
I don't understand.
You don't understand it, okay. I said, remember, every letter that is different, I'm going to treat it, that is the same, I'm going to treat it as different. So meaning the 2 A's there, I'm taking them as A and A prime. Take it as though it's a different letter, okay? So, in the first letter, the first letter, how many can I choose from? I can choose from the 7 from algebra, including A and A prime. Okay? So that would be 7. Once I've used 1, remember, these are the letters that I'm choosing from. So imagine if there was blocks and I've picked 1 already. So I've got 6 that are left, right? And then that means I've got 6. If I choose another one, then I've got 5.
Actually, one confusion was because they said how many 7-letter arrangements can be made. Therefore, if you're picking one and you're not repeating, then does it still make it a 7-letter arrangement?
Yeah, but that's where this came from. Because I said, if repetition is not allowed, right? That's why I said to you, the problem with this question, it's the question that is the problem, right? It can't be 7-letter if I'm not allowed to repeat. You see, and that's what I was showing you in the second instance. Okay, because then if repetition is not allowed, once I've used the one A, I can't repeat again, and there's no other letter that I can pick from. Do you understand? Okay, so we are left with this combination. So yeah, it's in the phrasing of this question that where the problem arises. So in order to answer it, assuming that we are making a 7-letter word, we'll have to assume that the 2 letters that are the same are different. That's why I call the other one A prime. Okay? So A and A prime, we assume that they are different letters.
Each say, I'm not understanding. So then what would make it 7 times 7 times 7 times 7 times 7?
Repetition is not allowed. Mamela, I'm picking from a basket in a mallet. Imagine if there were blocks, right? Once I've picked one block, how many blocks are left there? I've got 6. Do you see? So in that case, I can't repeat the block. Okay? There's a hand. Maybe Uzo answer a little bit better. Yeah. Oh, it's a question. I thought you were answering her. Okay, guys, I need to close this session. Okay? Yeah?
And I took draw the board to make you see where I'm getting this wrong.
Okay. All right. Yeah.
Like the algebra word has 7 letters.
Yes.
And then they said like how many different 7-letter arrangements can be formed. Hence, notice that some letters repeat. So does that mean that on the 7th position that they've given us, that the first block we have like on the algebra word we had to pick up.
You have to pick one of the words from algebra.
And
okay.
Then put it on the first position.
On the first position.
Yeah.
Yeah.
And then what about from the 6
Yeah.
position to
Yeah.
the last position?
Yeah. What about it?
Like
What about
shouldn't we have to pick from algebra again?
Okay, all right. Let me explain this again. Imagine algebra was made out of people who were holding placards, right? People. So imagine 7 people that are in a row, and we are trying to make different words. So the word can be, okay, let's pick letters at random. The word can be G, L, A, E, A, R, B. Do you get it? Okay. It doesn't have to be a word that makes sense to you. I'm saying we're picking a letter. Do you get it now? So what I'm saying is, if I pick the first person, can I have this person standing in one position and having them stand in another? No, it's not possible. So once I've picked the person, I no longer have that person as an option. Make sense? Right? How many people are still left? 6. I pick randomly another person. Right? How many people are left? 5. Do you get the sequence here, Con? So I'm saying this word, imagine they had it printed on their t-shirts. Yeah. If that makes sense. Right? So you can make different combinations from that. My problem though is that again, Lorraine, you were saying if we treated that as 7, I don't know. Sorry, first, did I answer your question? Hi, you are still unsatisfied. I guys, I am closing this. Okay, yeah.
So just maybe if you write the word algebra, then you cut small pieces.
I cut small pieces. Yeah, but the problem here, I'm going to 9:38 and I need to close. We can do that together. Is that okay? Is that okay, nah? Yeah, let's do that. Let's do that. For those of you that are joining us online, thank you so much. We want to leave it here for our lesson. Sorry that we've gone over time. We'll see you on Wednesday. We are doing electrodynamics. That is on physical science. Please join us at 10 o'clock. From me for now, I'll see you guys next time. Sharp, sharp. The other online people, I was talking to the people on our YouTube. Yeah, did it make sense to all of you?